You can set that aside and you can finish up as we have some downtime. If you missed yesterday, the packets are in the red crate named General Chem. And I did put up period 3 and period 4. They are YouTube videos, so you have to watch them through YouTube. But they are there. Well, today we're going to work on 4.2. And this is, I really like this part of the unit, so we'll see how you guys like it. Some kids catch on really fast, and others have a little bit of a struggle. So, we're going to go over ionic bonding today. We're going to go over 2 types of ionic bonding. Now, if you go anywhere else in the world, they're not going to call these type 1 and type 2. I've basically taken naming and broken it down into 4 different types for you, because it's a lot easier to say, oh, remember that's type 1, and you hopefully get a picture in your mind of what that is, instead of saying, remember that's ionic bonding with specific charges. Do you remember where on the chart that is? I can just say, that's type 1. Do you remember that? Instead of saying type 2, remember that's the one that has lots of different charges, and depending on what charge it has, you have got to do this or this or this or this. I can just say, it's type 2, remember? And hopefully that will bring up the image of what we're going to do. I'm going to give you some tricks to help remember things. So you might need to take a little bit of extra notes. Remember, you've got the back of your green paper that's on the front that you might want to take some extra notes on, because your notes today start right with a grid, right? And there's really no place to write. I'm going to, before we get to the grid, give you some little tricks to do stuff. So you might want to start on the back of your green paper. Okay? By the end of the day, you should turn in daily work 4.2. If you haven't uploaded 4.1, make sure you get that uploaded today. We had most of you uploaded last time, but there was a few of you that didn't get it uploaded, so make sure that gets uploaded. Ionic bonds are given and are taken, not shared. So we end up having a positive and a negative, and we call that electrostatically attached. And so what I think about ionic bonds is it's like you're staticking a balloon to you. The balloon's attached to you, but not really attached. Does that make sense? The reason it's attracted to you because it has an opposite charge. Okay? So, with type 1 metals, if you want to just draw yourself a really quick periodic table, it doesn't have to be real fast, just the shape, like I usually do. We're going to talk about how this type 1 works. So, for type 1, the first column is +1. You'll notice I did not highlight. You want to make sure, you might, like I said, I'm going to give you a little extra note so it's in your packet. So, if you use all the back of the green, you might want to grab another piece of paper too. I didn't highlight hydrogen. Hydrogen's its own group. Okay, so the first column will have a +1 charge. The second column is going to have a what, you think? +2 charge. These charges don't change. They only have these charges. And then I call this next part the slide. So think of a kid's slide. Usually there's a little platform at the top and then it goes down, right? And some of them have a little thing beside that. So these 3 right here, boron, aluminum, gallium, they will always have a +3 charge. That charge doesn't change. And then zinc right here has a +2 charge. And silver right here has a +1 charge. These are the only ones that have a specific positive charge. So I call them type 1 because their charges don't change. Okay, so if you remember which ones they are, this makes naming this type really easy. Do I need to stay here for a minute, or are we okay to move on? Stay for a minute? Okay. So these are metal ions that just have 1 charge. And on this slide, that's boron, aluminum, gallium, then zinc, and silver. You can sort of see it's like a slide. 3, 3, 3, 2, 1. Okay? You can think of the slide at the first being very steep and then sort of fades out. Okay? Have we got those down? We're still waiting? Okay. Now remember that first column does not include hydrogen. So get yourself a note that says it doesn't include hydrogen. Okay, hydrogen's not included on that first column. Okay? We okay to move forward? Want to make sure everybody got that down. Okay. So when we go to write the formula for, you're coming to get these, I don't know what's going on, so maybe you can tell me and I can help that fix that. When you go to write a formula on these, it makes it really easy. So let's take and do these together. Lithium's in what column? First one. So it's going to be Li with a positive 1 charge. And we usually don't write the 1, but I'm just going to write the positive there. So now we're back to your grid. Sulfide, the IDE just tells me that it's a negative element. So because it's a negative element, I'm going to look on the right-hand side of the periodic table. What would be a sulfide? Sulfur. How many away from being a noble gas is it? 2. So it's going to be a negative 2 charge. So it's S2 minus. Now this is where you got to use your math skills. Oh, it's not too hard though. Okay? Usually we don't get up above, say, 10. If you can add or subtract 10, you're good. So how many plus 1s do I need to add to how many minus 2s to get 0? Because it has to add to 0. So how many? 2. So I'm going to say Li, I need 2 of them to go with 1s, and I've done my formula. Okay, find calcium. Remember, it will be on the left-hand side or in the slide. What's calcium? Plus 2. It's in the second column. So it's capital C, little a, with a 2 plus. We usually write the number first. I don't know why. Fluoride. That would be on the right-hand side. What's a fluoride? I means it's going to be a negative. I have a negative 5. Is that right? Negative 1. Which one do we believe? Negative 5, negative 1? Negative 1? Okay, fluorine is 1 away from being a noble gas, isn't it? And the I just told me it was a negative, so I don't really worry about the I right now. It's fluorine. Fluorine's 1 away from being a noble gas, so it just needs 1. So I'm going to put fluorine here as a negative. Okay, this time I have a 2 plus and I have a negative 1. I have to make them add to 0. So how many of each do I need? How many calciums do I need? 1, right? I don't write a subscript 1. I just write the Ca. How many fluorines do I need to add to that plus 2 to equal 0? 2. So I'm going to put capital F with a subscript 2. How are we doing so far? Okay, let's go. Let's try strontium. I want you to see if you can do it on your own. Find strontium. Strontium. Was that a quick fix? Yeah. Okay, you'll have to let me know what it was so I can do it by myself. If, so I just needed a reboot? Because I tried to restart one and it didn't work. Yeah, just hold the power button for about 20 seconds so it'll do a hard shutdown. Okay, I will do that. Thank you. Okay. Did I give you enough time or you need a little bit more? Let's see how we did. What's strontium? What's the symbol? What's the symbol for strontium? Capital S, lowercase r. What's the charge? 2 plus. Good. It's in the second column. Bromide. What element is that? Bromine. What's the symbol for bromine? Capital B, lowercase r. What's its charge? Negative. Okay, so what is my formula to make it add to 0? SRBR. So you're seeing how many away from a noble gas it is. So on the negative, I want to say, the first one I know the specific charge. I know the positive. The second one's always going to be negative, and how many do I need to get to it to a noble gas?
Just like, so you basically, if it was like a sulfur, would you just count 1, 2?
Yep. Yep. Okay, good job. Let's keep going. I want you to keep trying. We're going to put it up slowly. So talk to your neighbor, check on with your neighbor really quick. We can pair share and see if they're getting the same answers you are. I'll walk around the room. If you need help, I'll help you. If you get done, you can go back to your quiz. If you did not get a good job on your quiz or you didn't finish it, you can do that. packets over here in Gen Chem crate. Okay. Yes.
This is 1.
Plus 1. Yeah, but it doesn't include hydrogen. This is plus 2. 3, 3, 3, 2, 1. So just those specific ones. And nope, just silver. Yeah, I want you to do just this grid down through barium fluoride.
Everything else is negative.
We'll get to the rest of them. But, so chloride is what? Chloride just tells me it was negative, right? The IDE. So what would be what's chlorine? Mm-hmm. Yeah, if the ending is changed to IDE, that just tells me it's negative. Okay, I'm going to put magnesium chloride up. Let's see how you did. Oh, oxygen, good. Oxide would be coming from oxygen. How do we do on magnesium chloride? Thumbs up, I got it. Thumbs down, I didn't. Thumbs sideways, I got the ions.
I got it, but I don't understand it.
Okay, keep going. Let's see if we can do it. All the way through barium fluoride. Good job. Oh, yep. You got it. Yes, ma'am. Yes. Yep. ID just tells me it's a negative. So they change the ending of the element if it's negative. So far, so good. Okay, I'm going to put up the next one. Let's see how you did on this one. Okay, I'll give you about another 15 seconds to do the last one, then we're going to come back together and talk about type 2. After we might. Actually, on your computers or on your phones, would you bring up poll everywhere? I'm going to give you a little poll, see how we're doing as a group. I'm going to give you one to try. Okay, how do we do on that last one? Yes? Got it? Okay, here's your poll that you want to go to. So poll everywhere, either on your phone or on the computer. Okay? I want to see where everybody's at. So either on the computer or the phone, you're wanting to answer the question, what is the formula for calcium phosphide? Calcium phosphide. I was like, I don't know. It's capital there, so I don't know. No, online or text, whichever you want to do. Online or text. Okay? And there are some choices, so let me bring that up. Whoops, sorry. Trying to find out where I had it. Not there. It's got to be over here. Right there. Somebody wanted it and then didn't want it. That's funny. So here's your choices.
So which one's right?
You've got to figure it out. Look at the charges. Find the charges of what calcium is and what phosphorus, right? Because phosphorus would be phosphide. What they would be, they've got to add to equal 0. Got to add to equal 0. So find a common factor they both go into. Now we're 33%. Ooh. Okay. Remember, it's got to add to equal 0. Has to add to equal 0. Now we've got another one beaten out at 1. Okay, I'll give you about another 30 seconds. Put your answer in. Got a little fluctuation going on. How many of each do you need to add to equal 0? Okay, make a decision. Last call. Yes. So you're going to go on your computer, pollev.com/Stacy Howell 014. So you just put that in your computer, pollev.com. We're going to be using this again, so don't take it down. And on the computer, it actually shows you big, these things right here, even though I put them in small. It's awesome. Okay. So, while you're finishing up here, I'm going to bring up white sheet of paper, hopefully coming up. That's just slow. Okay, let's look at this. Okay, so most of you, whoops, let's try that again. Most of you chose this. Let's figure out why some of you chose this, and that one now is minuscule. So calcium had what charge? 2 plus, good. And phosphorus, which was phosphide, had what charge? It was 3 away from being a noble gas, so it's 3 negative. Well, 2 and 3 go into what number? 6, you got to times. So how many calciums do I need to make 6? 3 times 2 is 6. How many do I need to times this by to get to negative 6? 2. So as I write it, Ca3, P2. Can everybody see what they did wrong? Okay. So I know a lot of kids say, well, just crisscross it. It works if they're odds or they're primes, but if they're not, it doesn't work. So just get used to putting in your head, oh, what do both of these numbers go into? So if I had a 2 and a 4, what do both of the numbers go into? 4. Does that make sense? So I'd need 2 of one to make up 1 of the other. Okay, so let's go ahead. Let's do one more right here real quick. I'm going to give you, let's see. Let's do aluminum and oxygen. Okay, aluminum and oxygen. Go ahead and just write it down somewhere. Figure out how much of each you need and what the formula would be for aluminum and oxygen. Aluminum's part of the slide. Aluminum's part of the slide, so it has a specific charge that I gave you just a minute ago. Mm-hmm. Okay, another 15 seconds. See if you can figure out what the formula is. Write it down. Commit to it. Got it? Got it written down? Okay, let's see what you did. Aluminum has what charge? 3 plus. What does oxygen have? It's 2 away from being a noble gas, so it's minus 2. Common factor here is 6. So how many 3's do I need to make 6? 2, right? 2 times 3, you're timesing it. So 2 times 3 is 6, right? What times negative 2 is negative 6? 3. So that means I need Al, I need 2 of them, and oxygen, I need 3. If you got that right, thumbs up. If you didn't get that right, thumbs down. Okay, so it looks like we're getting, does that make sense? Before we go on, we need to make sure we have this down. Do we want to do one more, or are we okay? Yeah, it's still working on the poll. Somebody's having fun with it. Okay, so let's do one more. I want to try this one with you. So let's do, zinc. And let's do C. But here I'm going to give you the charge of C as being a -4 because it's going to be the carbide, not carbon. Right, but it's part of our slide. That's when I gave you a charge for. Zinc is part of the slide where I told you, remember, boron, aluminum, gallium +3. Zinc +2, silver +1. Okay, let's see if we get this one right. Pull that out of the way for a minute. Whoops, and I just went away from the other. So this was a 2+, right? You should have written this as a 4-. Okay. What's a common factor? 4. So how many 2's do I need to make 4? I need 2. How many 4's do I need to make 4? Okay, I don't write ones as subscripts. So I'm just going to write Zn with a 2 and a C, zinc carbide. Done. Right, but we want the lowest number they both go into. So the lowest number both 2 and 4 go into is 4, right? Yes? Okay, so we want the lowest number they both go into. All right, so let's go ahead and if you want to take and now I'm going to give you a little bit of notes on type 2. So if you want to go back to wherever you were writing your notes because we've got that grid again. Type 2. These are ones that have different charges, and because they have different charges, I need to say what charge I'm using, because they have lots of different charges. This is the D, the F, and the lower part of the P, so below the diagonal in the P. These elements, these metals, have lots and lots of different charges, so if you want to write yourself a little note, type 2, D, F, and the lower part of the P. Just write it down somewhere. So type 2. So we did type 1. We knew the charges. The charges were known. Type 2, the charges are not known. There's a lot of different charges here. So these are the metals that are in the D. Now, we don't count silver and zinc because they were part of the slide. But the others, in the D, the F, and the lower P, these have multiple charges. So we're going to use this type of naming for them. Okay? So the diagonal is boron, silicon, this one right here. We actually have the metalloids. Remember the metalloids? These are metalloids. So it's the ones that are not the metalloids and the ones that are not part of my slide. So my slide, remember, is these and this and this. That's my slide. That was type 1. So it can't be the diagonal because those are metalloids. It has to be a metal. Okay? Good questions. All right, so this is how these work. We use Roman numerals. We use Roman numerals to tell the charge on the metal. Now, if you don't know your Roman numerals, here they are. You better write them down because you're going to be using them. Okay, so I is 1, I is 2, I is 3, V is 4, V is 5, VI is 6, VII is 7, VIII is 8, IX is 9, and X is 10. That's as high as we'll go. So if you know your Roman numerals, you're good to go. If you don't know your Roman numerals, please write them down. And then just say we use Roman numerals when we have elements in the D, the F, or the lower P, not including the slide. Okay, not including the slide. So that's type 2. So when I'm telling you it's type 2, I better see a Roman numeral. Okay? All right, so now we're going to practice this type and see how well we do with it. Did everybody have a chance to write down the Roman numerals that doesn't know how to do them? Okay, pretty standard. You can probably Google it if you need it for the first little bit too. Okay, so doing it with me. Technetium. It's got to be in the D, the F, or the lower P because of the Roman numeral. Can you find technetium? What's the symbol for technetium? TC. Good. So TC. This tells me the charge on that. What Roman numeral is that? It's a positive 6. So 6 plus. Then we go sulfide. That's going to be on the right-hand side because all the negatives are on the right-hand side. What's sulfide? Sulfur. And what charge does it have? 2 negative. What's the common factor that they can both go into? 6. Good. So technetium's already at 6, right? I just need one of them. How many sulfurs do I need to get to 6? 3. Good. So S3. Okay, next one. Cobalt, and then that's the charge. What's the symbols for cobalt? Okay, overemphasize that the O is little. Otherwise it looks like carbon oxygen. So you got to really overemphasize that it's little. And what was the charge on it? That is a Roman numeral 4. Good. So 4 plus. Fluoride, what's that? Fluorine, which is what symbol? F, and it's a 1 negative. Good. All right, what's the common factor? 4. Cobalt's already at 4, right? I just write one of them. How many fluorines do I need? I need 4 because it's only a minus 1. Done. Okay, tin. What is a symbol for tin? SN. Good. Where is it? It's in the lower part of the P, right? So the lower part of the P, number 50 if you missed it. What is the charge? 2. Good. And it's a plus, right? Chloride. What's that? Chlorine, and it's Cl, right? What's the charge? Negative. What's the common factor here? 2. How many SNs do I need? How many chlorines do I need? Okay, you do the rest real quickly. I'm going to wander around. If you need help or you're totally lost, please let me know. This is important. We know how to do this.
Is it always going to be positive?
Yes.
Okay.
The Roman numeral always tells me the positive one.
Okay. All right.
Good question.
What's bromide?
Bromine. So cadmium would be right here. Oh, lead. Okay. So lead's right here. This tells me the charge. So 5 minus 1 is 4. So this is plus 4. That's the Roman numeral for 4. So put a 4 plus right there. Bromide is bromine, which is Br. So that goes here. And it's 1 away from being a noble gas. So it's going to be a negative 1. So I put a negative 1 there. So the common factor here between 4 and 1 is what? 4. How many leads do I need to get to 4? 1, right? So I just write PB, capital P, little b. And then how many negative 1s do I need to get to a negative 4? So you put a subscript 4. And then just make sure your first letter is always capital. So that capital T there. Okay, so then you look at cadmium. Cadmium's right here. What charge was it going to be? So write it there. And sulfide is sulfur. How many away from a noble gas is it? Okay, so what charge is it going to be? Right? Common factor for both of them is 2, right? 2 plus and minus 2 is already 2, so just smash them together. Okay, do the last one on your own. Okay, I'm going to put 2 of them up. Let's see how you did on the first 2, and then I'll wait for the last one for a minute. Cadmium is number 48. Okay, here comes the last one. Okay, I got all the 3 last right, thumbs up. I got 1 wrong, thumbs sideways. I got 2 or more wrong, thumbs down. Okay, we're doing better. All right, we're going to go to another poll and see how you do on this one. Same kind of stuff. We're just going to now look at the next, this one. So we're going to go next. Okay, it's the same poll. Hopefully you can see it. So this is vanadium, Roman numeral Vi, sulfide. Yeah, you just have to do next. It should be next. It should be the next one, I'm hoping. I think so. Somebody just changed. Uh-oh. Okay, as quickly as you figure it out, put it up there.
There it is. It's 23. Yeah. I'm going to say that I picked. Because I can't respond to the polls. Well, that's sad. Okay, undo.
Okay, 30 more seconds. Let's see what we do. Okay, I'm going to bring up the little white paper here. Let's talk it through. Most of you picked VS3. There's a couple that were not there, so I want to make sure we get it right. So it was vanadium with a 6+ charge, right? And we were putting it with sulfur, which is 2 away from being a noble gas, so it's a -2. What's the common factor? 6. So this one we just need 1 of. How many of this do we need to get to 6? 3. So when I write it, it's VS3, which is E. Does everybody see that? Okay. We're going to go back to the PowerPoint really quickly, hopefully. Oh, and it went off. So let's go here. Okay, so we now are going to add what's called polyatomics. Polyatomics are groups of elements that hang together. Okay? They're like a gang. Okay? Most of them have negative charges. That's why I call them a gang. These 4s are supposed to be down. They didn't do very well. But we do have 1 or 2 positive gangs, sort of like Latinos in Action or the Hope Squad. Okay, we have a few gangs that are positive. NH4 is one of them. That's ammonium. Okay, the other one is mercury 1. If you look at the back of your periodic table, you'll see an area that says polyatomics, and they have charges, and they have their names by them. You see that? Okay, these ones are specific to what we're doing. Whoops. They're on the back. That looks like, whoops, I was going the right way. Looks like this on the back of your periodic table. Okay, you remember seeing this? Okay, we're going to be using these groups now because not all compounds are just one element and another element. Yes. So you find them on the back of your periodic table. Okay, they're found on the back of your periodic table. They're groups of elements that hang together and have an overall charge. Most polyatomics or gangs are negative, right? There are a few that can be positive, though. All right? So your positive ones are right here. Those are the only positive ones. That's it. So there's not very many. And these are not all the polyatomics there are. There's a lot more than this. Okay? These are just the ones we use the most often. So, I like this. So you think you know all your polyatomic ions. You've got them on the back of your periodic table. Do you know what thiocyanate is? This is what thiocyanate is. This is it's used in pharmaceutical industries. Potassium thiocyanate is a raw material. It's used in chemotherapeutic drugs, antibiotics, and to treat thyroid medications. In industry, it's used for photography, textiles, and to manufacture herbicides, fungicides, and pesticides. Okay? So, let's see what we can do with polyatomics now. So have that back open. You're going to be flipping back and forth between the front of your periodic table and the back. So, ammonium. What did I tell you about ammonium? That's one of your only positive polyatomic ions. So look for ammonium in your positive polyatomic ions. What is it? NH4 with a positive charge. So we're going to put that there. The negative ion here is sulfide. For the most part, when it ends in IDE, it just means it's an element. There are a couple of exceptions. Cyanide and hydroxide are not just elements. Okay, on thiocyanide we just saw. Those are polyatomic, so you got to look on the back. But if it has an IDE ending, for the most part, it's an element. So sulfide would be what? Sulfur. What's the charge on sulfur? 2 negative. Okay. What's a common factor?
Where did you find that ammonium?
Ammonium is on the back in that polyatomic thing on the positive end. So it's on the bottom right-hand corner of that polyatomic. Yep. Okay, so the common factor here is 2, right? Now here's the trick, guys. Everybody, eyes on me. 1, 2, 3, eyes on me. Elementary school, right? Okay. If I need more than one of a group to balance out the charge to make it equal 0, I have to put that group in parentheses. So I have to pick it up as a group and say I need 2 of these groups. Okay? I need 2 of this ammonia group to balance out one of that sulfur group, right? So, parenthesis, NH4, so I put that group in parenthesis. I need 2 of that group, so I put on the outside of the parenthesis the 2. Then I need also 1 sulfur. Not too bad though. Just think of it as I need 2 of those groups. I've got to hold those groups in parentheses. Okay? Well, I have ammonium has a +1 charge. I need 2 +1 charges to balance out sulfur's 2 negative to add to 0, right? So if I were writing a formula or an equation, I'd say +1, how many of these do I need? Plus -2, how many of these do I need to add to equal 0, right? So here I would put, I need 2 of these to go with 1 of those, right? That's what I've done right here. I need 2 of these to go with 1 of those. I don't write ones.
Oh, is that not part of sodium hydroxide?
Right, I'm just writing a formula. Okay, so let's do this next part. Sodium. Element or polyatomic? Element, first column, right? So Na with a plus, right? Hydroxide. Ooh, this is one of those exceptions to the rules I told you watch for. The IDE is usually an element, but hydroxide's a polyatomic. It's an OH negative. Good. I got a +1, I got a -1. They already add to 0, right? I just smash them together. NaOH. I do not use parentheses if I only need 1 of a group. Do not use parentheses if I only need 1 of a group. Okay, here we go. Now we're mixing in type 2 here. Indium. What's indium?
3+.
It's a 3+. What is the symbol for indium? IN, it's number 49. So capital I, and we do use the end caps on the I's, okay? And then N. So end caps, like top and bottom, for the capital. All right, nitrate. 8, ite are going to be polyatomics. Look on the back. 8 and ite are going to be polyatomics. Look on the back. NO8. This is an 8. It's a 3 and a negative. Be careful. There's a difference between 8 and ite. Okay? All right. What's a common factor? 3. Indium I need how many of? 1. How many nitrates do I need? I need 3 of these, right? Charges. I'm balancing the charges, not how many. I'm balancing the charges. So I put NO3 in a parentheses, and outside the parentheses I put another 3. Saying I need 3 of these groups. Okay? Because each group only has, each group only has a -1 charge. So I need 3 NO3 groups to balance out 1 indium. Okay? So it's like if a school has one large chem club, I'll use chem club, and another school has just a few and just a few, and another school and just a few and another school. In order for them to have a competition, we have to put these 3 schools together so they have enough to compete with the big school. Okay? So same thing here. This has only got a -1 charge, but it still has a group. It still has a game. Okay? All right, next one. Magnesium, what is it? Mg. What's the charge on magnesium? 2+. It's in the second column, so that's type 1. Sulfide. I'm mixing these up a little bit. What's sulfide? Sulfur. It's an element. Okay, sulfur has what charge? How many away from the noble gases are sulfur? 2, so it's going to be -2. +2 -2. Smash them. They already add up to 0, right? Don't have to do anything. Okay, palladium. What in the world is that? Well, Roman numeral, that tells me it's going to be the D, the F, or the lower P, so that's where I'm looking. PD. Okay, so capital P, lowercase d, and it's a 4+. Good. Sulfite. SO3 negative what? 2. Good. Common factor.
So if it's ITE, it's a poly.
If it's ITE or an ATE, it's definitely a polyatomic.
And if it's IDE, type of 1.
There's 2 that are IDE, well, there's 3 that are IDE that are not elements. Thiocyanide, cyanide, and hydroxide.
Okay, well, I get 2 different numbers on the SO3.
So SO3, that's the group. It has a 2 negative charge. Okay? All right, so the common factor was what?
So then what 2 numbers are you trying to find?
4.
The charges?
The charges. So I want them to add to 0. What's the easiest way to get them to add to 0? How many palladiums do I need? 1. How many sulfites do I need? 2. And since it's a group, what do I need to make sure I do? Put it in parentheses. SO3, parenthesis 2. Okay, you do the last one. Lithium phosphate. Lithium phosphate. Okay, give you a few minutes. Try and do it on your own. Then we're going to do another poll everywhere.
Did I do it right now?
Phosphate 8. It's going to be a polyatomic. It's going to be a polyatomic. Fate, 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 fate.
Phosphate is not.
Okay, how did we do on this last one? Did you get it? This one, the gang or the group had a -3 charge, so I needed 3 lithiums to balance out that phosphate. So you should have written Li3PO4. Thumbs up, strong, I got it. Thumbs sideways, I'm still really confused. And thumbs down, I'm not getting this at all. Okay. All right, we're going to try poll everywhere now again. Let's see how well you do. We're going to go to next, and we're going to activate it. Okay, this is lead IV nitrate. Lead IV nitrate. Lead IV nitrate. Lead is right here. Okay, I want to see some results from everybody. Come on. So lead IV nitrate. It looks like most of the class is picking E. Let's look at it. Okay, so PB, since it was an IV, what number of Roman numerals is that? It's 4. So we're going to have a 4 plus, and then we had it with nitrate. And you should have looked on the back of your periodic table. Nitrate is NO3 and has a -1 charge. What's the common factor then? 4. Good. So how many leads do I need to make 4? 1. How many nitrates do I need to make 4? 4. So when I put it together, PB, but I need to put nitrate in parentheses, and on the outside I need to put the 4. So E was correct. E was correct. Okay, let's go back to here. Keeps kicking me out. I don't know why. Okay, so we just finished that. That's the end of your notes for today. So you just need to finish your practice, and there is some review on the practice. Okay? Type 1 naming, type 2 naming. We've got 4 total types of naming that we're going to be going to. So we did 2 today. You're going to write simple formulas. You're going to write simple formulas with polyatomics, and you're going to write more complex formulas. So you have the rest of the time to work on your assignment. I'm going to be wandering around the class. We're not moving today in rotations. I am just going to wander around the class. Pull me in if you're lost or need help. Make sure you get this uploaded before you leave. iPads are on the computer thing, okay? All right, here we go. Go stop this video.